So, the other interrupt that we have in 8085 is the trap interrupt. So, this is equivalent to RST 4.5 and this is the only non-maskable interrupt. So, you cannot, it is not affected by that EIDI instructions. Okay. So, it is always enabled. So, it does not need to be enabled because it cannot be disabled. So, there is no question of enabling it, and the priority is the highest among all the interrupts. So, this is the highest priority interrupt. So, even if some other interrupt has occurred and we are in the ISR, even if that EI instruction is not yet executed, if there is an interrupt on the trap line, so it will be sensed by the microprocessor and it will go into the processing of it. So, that makes it a very useful for very useful interrupt for handling critical situation. Second important point to note is that it is usually used for power failure, emergency shut off. So, this type of cases, so this type of applications, this trap interrupt is used. So, power failure is a situation where if the power goes off, so there is definitely battery backup, but the emergency operations that are going on, we need to take a log of that, so that after some time the battery will also go off. So, at that time we will be able to restart the operation from the from that point onwards. So, or maybe the system has got some modules which are power hungry, particularly the peripherals, they are power hungry and those peripherals are to be shut off, they cannot run on the battery. So, that way this system designer can decide like what are the components that needs to be shut down when the normal power goes off and it is on the battery backup. So, this trap interrupt line can be connected to the power supply from the power supply point, and if there is a power failure, then the system will get an interrupt and the essential activities can take place. The important thing to note is that it is both edge and level sensitive. So, for sensing of this interrupt, so the edge should be there and the level should also be level is also taken level is also to be considered. Okay. So, it is like this. So, if this is my microprocessor and this is the trap line. So, this is the trap line. So, what is required is that there will be an edge followed by this level. Okay. So, there will be some minimum duration for which this the level should be, the signal should remain high. So, this edge should be there plus this level should be there. So, it is connected to it is it will be sensed only if both of them are there. So, this makes it a slightly different compared to the simple edge sensitive one and the level sensitive interrupts. So, so level sensitive interrupts means they need to be turned on for quite some time, and edge means that it will be any activity occurring, so it will get sensed. So, both of them have got problems because when the power supply line you are connecting to the interrupt pin. So, if there is a flicker in the power supply line, so it will be taken as an interrupt if it is only edge triggered. On the other hand, maybe that the flicker comes and goes. So, it is not affecting the system too much. So, we do not need to shut down the other IO devices. So, in that case, that level sensitive, the minimum duration of level, so that will come into picture. So, interrupt will not be sensed that way. So, this is important. So, that is why it has been made both edge and level sensitive. So, it needs to be high and stay high to be recognized. So, that is the first thing, and once it is recognized, it will not be recognized until it goes low and then high again. So, there is low to high transition is important and it has to remain high for some time. So, that is also important. So, if you look into this priority of these interrupts, that internal priorities. So, the trap has got the highest priority, followed by 7.5, RST 7.5, RST 6.5, RST 5.5, INTR. Okay. So, this is the order. However, trap has lower priority than the hold signal used for DMA. So, we will come to that. So, there if you remember, there are two pins, hold and hold acknowledge, available in 8085. So, they are used for a particular type of data transfer which is known as direct memory access or DMA. So, in those cases these signals will be activated. So, if trap and hold both are activated simultaneously, then hold has got the higher priority than the trap. So, why this thing happens? So, we will see that later once we go to the DMA controller part. So, then we will explain this thing. So, to summarize, so we have got all these interrupts. So, INTR, RST 5.5, 6.5, 7.5 and trap. Out of them all of them are maskable excepting this trap. So, masking method for INTR we do not have this individual flip flops. So, we have got this interrupt enable flip flop. So, these DI and EI instructions can be used for masking this interrupt pin INTR pin. Whereas, for 6.5, 5.5, 6.5 and 7.5 we have got two ways to do this masking. One is via DI EI, another is by using the SIM instruction. So, we know that there is the individual flip flop for enabling disabling of these RSTs. So, they can be utilized using the SIM instruction, and DI and EI will be affecting the interrupt enable flag. So, as a result the entire thing will be disabled. Trap cannot be masked. So, this is the only non-maskable interrupt that 8085 has. Next is, if you try to classify with respect to the vectoring. So, INTR is not vectored, because so when INTR occurs there is no fixed address to which the processor will jump compared to 5.5, 6.5 and 7.5. So, we know that these values multiplied by 8. So, whatever be the location, so the processor will jump to that location, and it will expect that the ISR for the interrupt will be starting from that address. Whereas, for INTR we do not have anything. So, for INTR what happened? INTR the processor enters into an interrupt acknowledge machine cycle, and then it expects that on that cycle the address of the ISR will be put on the data bus by the device, and the processor will take that address and then branch to that particular address. So, that way the INTR goes, but 5.5, 6.5, 7.5 and trap also. So, all of them are these they are all vectored interrupt. So, to get the vector address, so you just multiply this number by 8. So, trap is 4.5. So, multiply 4.5 by 8. Memory. So, whether they can remember that something has happened. So, when the processor was busy doing something else, maybe another ISR, at that time the interrupts were disabled maybe. So, at that time if something has happened, whether the system can remember that there is this interrupt has occurred. So, INTR 5.5 and 6.5, for them we do not have any memory. Similarly, for the trap also we do not have any memory. Only 7.5 has got this feature. So, remember that there is a memory element associated with 7.5 that stores the occurrence of the interrupt. So, that later on the processor may check the occurrence of that interrupt and look into that. Triggering method. So, this is INTR is level sensitive, 5.5, 6.5 they are also level sensitive, 7.5 is edge sensitive, and this trap. So, this is both level and edge sensitive. Okay. So, this way we can have different classification of the interrupts of 8085 from different angles. If you view, so you can come up with different classifications. Next, we look into another way of data transfer between the processor and the device. Okay. So, this is known as direct memory access. So, in a normal system, what happens is that whenever the IO device wants to transfer some data, so the philosophy may be like this, that the device sends an interrupt to the 8085, and as a result the 8085 goes into the corresponding interrupt service routine, and that interrupt service routine it reads from the device the data that it wants to transmit, or if there is some data to be outputted to a device, then the when the device is ready, it can send an interrupt to the processor telling that I am ready, and then the processor can start transmitting the data to the device through the data bus. However, what happens is that these devices that we are considering, they are most of the time they are mechanical device or electromechanical device, and many a times they involve human being. Like say there is a keyboard, if I connect a keyboard to the microprocessor, then when the user is pressing a key, maybe the interrupt is given to the processor that a key has been pressed. Okay. So, accordingly the processor will go into the ISR for that. Now, these users are much slower compared to this electronic processor that we are considering. So, if the if the every time user presses a key, so it is interrupted, so that way it takes quite some time. Or many a time we need to transfer data from the secondary storage, which is like say disk, to the primary memory, that is which is the RAM maybe in the system. So, when you are considering a complete computer system that has got processor, memory and secondary storage, so many a times we need to transfer the bulk of data from the secondary storage to the primary storage, or vice versa, from the primary storage to the secondary storage. Now, while this thing is going on, since the processor cannot do anything, so processor has to remain idle, so it cannot do any operation. So, to facilitate this process, so this direct memory access is a procedure by which we can transfer data between two peripherals directly without involving the microprocessor. So, there is a hold pin in the 8085 processor. This hold pin is used for this purpose. The DMA controller sends a signal on the hold pin to the microprocessor. When this the hold pin is activated by the external master, external DMA controller, and the microprocessor will complete the current operation and send a signal on the hold acknowledge and stop all the buses. Okay. So, all the buses are now floating and it is given to the DMA controller. So, DMA controller can now use the bus, and once it is done, once the DMA controller has finished the operation, it can turn off the hold signal and the microprocessor can take back the control of the bus. So, we will explain it with respect to one DMA controller. So, suppose we have got as a system consisting of the processor. This is the 8085 processor, and we have got so this 8085 processor has got the memory connected to it, and there is address bus, data bus and control bus. So, this is the address bus, this is the data bus, and this is the control, the read write control. Now, if there is another DMA controller, so this is another chip which is sorry. So, this is the DMA controller. So, there are some standard chips available. So, for that several such chips are available. So, DMA controller can it has also got this address, data and control lines. So, they can be connected to the DMA controller. So, this address, data and control lines can also be driven by the DMA controller, and it has got two extra pins. One is to give the hold signal to the microprocessor. So, this is the hold line, and in turn this microprocessor will respond with the hold acknowledge. Now, in this situation what happens is that whenever now if I have got some IO device, so these IO devices are connected to the DMA controller. Okay. So, these are this is a device 1, this is a device 2, like that. So, when these devices are ready for data transfer to the system, so what will happen is that they will tell the DMA controller, and DMA controller in turn will send a hold request to the 8085 processor. So, 8085 processor, it was executing some instruction. So, maybe it was executing say instruction I, which takes a total of say 4 machine cycles, and at present it is in the second machine cycle. When this hold has occurred, when this hold signal has been activated, the processor is in the second machine cycle of the instruction. So, what will happen? The processor will immediately suspend its operation. Okay. If it is going to accept that hold request, so it will suspend its operation, it will send the hold acknowledge signal to the DMA controller, and it will release the control of these buses. Okay. So, this processor will no more control these buses. So, now you can understand that the processor cannot do any memory read write operations now. Okay. So, the buses are released. So, after releasing the buses, the hold acknowledge is activated. So, DMA controller will know that the buses are now free. Now, the DMA controller will execute and it will transfer the bytes between the device and the memory using this address data and control buses. So, this is how this whole operation is done, and once this DMA controller is done with all the data transfer that it has to do, it will take off this hold signal and the 8085 will understand that okay, that hold signal has gone off. So, it can gain back the control of these 3 buses and continue its normal operation. So, you can in some sense you can say that since this processor is not using these external buses. So, 8085 from the outside world you can say that okay, as if this entire operation has frozen. Okay. So, it is not doing anything. So, entire operation is frozen, and unlike interrupt where if the interrupt had if an interrupt had occurred when the processor was executing this instruction I, which takes 4 machine cycles, and interrupt has occurred in the second machine cycle. So, we said that the processor completes the current instruction, okay, and then it goes into the interrupt service routine, whereas for this DMA operation. So, it does not happen like that. So, it completes the current machine cycle only and it goes to the DMA operation, because it is not doing any memory access. So, nothing is going to happen inside the processor. Okay. So, that is why it does not need to take care of this saving of it does not need to take care of completion of current instruction and all that. So, nothing. So, all the register contents are frozen, you can say. So, when this hold comes back, when the hold becomes deactivated, then the PC still contains the correct value. So, the instruction continues from the wherever it had stopped when the hold signal has occurred. So, this way this DMA controller can be operated, can be interfaced with the 8085, and that way we can do data transfer between device and memory, which is very fast. Otherwise, what will happen is that this 8085 it has to go into, so if this interrupt driven service, like if this D1 is allowed to interrupt the processor directly, then in that interrupt service routine. So, it has to read the data from device and put into memory. So, byte by byte it has to do that transfer, and possibly that is an overhead. So, in later processors, so we can see that when this DMA is activating, so 8085 this processor can do the internal operation. So, that way we can have some parallelism as well. Okay. So, this is the DMA direct memory access philosophy. So, we can have this thing, we can have this microprocessor will be put into a hold condition, and the DMA controller will be taking care of this transfer. Next, we will look into another very important concept, which is for the serial input output operation. Okay. The serial input output operation. So, we have to we want to transfer data serially, like while looking into that SIM and RIM instructions. So, we have seen that there are serial data input and serial data output, and also those bits were there in the RIM and SIM instructions. And also we have seen that there are serial the SID and SOD pins are available in 8085, through which the serial input can be activated. So, a very simple way of data transfer from processor through to the device may be serially through these SID SOD pins. Okay. So, to do this operation, so we have to transfer, we have to look into this serial IO part. So, with the basic requirements are like this. So, we need to identify the device through a port number. So, this one may be mapped onto the memory, or it may be mapped onto the peripheral. So, which is identified by that IO M bar line. So, we will come to this later. Then we enable the device using read write control. We read for an input device and write for an output device, and only one data line is used to transfer information instead of the entire data bus. So, this is how this is serial data transmission will take place. So, we need to have some number, then we to identify the device, then we should have some read write control for reading from the input device or writing for the output device, and we have to have only one data line can be used for transferring the data. So, we will take some example. So, when it is microprocessor controlled, so it is unconditional polling or status check. So, these are the things to be done. So, maybe my microprocessor transfers the data from one IO to from the memory to the device, or it may be interrupt driven. So, this is this will be true when we are having say interfacing using say normal operation. Okay. So, say when we are having say this is the, so suppose we have got this as the microprocessor 8085, and we have to connect, we have connected a number of devices. So, this is a D1, D2, D3 like that. So, each device will have some address, and that address is identified by something like some sort of say chip select signal. So, these chip select signals will be coming. So, CS bar 1, CS bar 2, CS bar 3, some chip select signals can be there. So, the address lines that are generated from the microprocessor, the address bus. So, this address bus, it has to go through a decoder, address decoder, and accordingly it will generate a number of enable lines, and these enable lines are to be connected to the chip select lines. These enable lines are to be connected to the chip select line. So, that based on the address that is generated, so one of these devices will get selected, and from the data bus I can connect to all these devices. Okay. This data bus can be connected to all these devices. So, it may be, if it is say if D1 is an input device, so the data this direction will be like this. So, if D2 is an output device, direction will be like this. So, D3 may be another output device, the direction will be like this. So, this is the data bus from the microprocessor, and also we have to give the read write signals. Okay. The read write signals are to be activated. So, I am not showing it explicitly there, but that read write signals will be there. Now, so this type of transfer, so how this can happen? So, this 8085, so it can the processor can determine, okay, I will send some data to D2. So, it will send some, it will put the appropriate address on the address bus, and this D2, this chip select will be activated, and the data will be sent through the D2 line to the data bus to the D2 device. Similarly, when it decides to send something to D3, so it can do that way. So, that may be one possibility. So, other possibility is that instead of connecting it like this, so these devices when they are ready, they send interrupt to the 8085. Okay. So, through the interrupt they can be connected through the interrupt line, and as we have seen that if I have got multiple devices, then I can have some in between and interrupt controller, and then interrupt controller may be this that it can resolve the priorities and send interrupt to the processor. So, it can do it like that. So, that way, so in case of interrupt driven, what happens is that when the interrupt comes, the processor will go to the interrupt service routine, and then it will do the transfer. So, this type of communication that we are talking about, so they are basically the parallel type of communication. They are parallel communication because we are sending 8 bits of data simultaneously between the processor and the device. But the interfacing this device, the challenge that we have is, first of all we have to have this decoder, plus we have to have these 8 lines running. So, many lines need to run through the chip. So, instead of that, so what we have in 8085 is there is another facility which is the serial input. So, SID and SOD pins are there, SID and SOD pins are there. So, anything that you want to input from a device, so if you can connect it to the SID, the serial input data, so it can be it can transfer data, it can read data from the device serially 1 bit at a time. So, this line width is 1 bit. Similarly, we can have the SOD, serial output data. So, if I want to output something to the device, so again the 1 bit connection can be there. So, instead of parallel connection, so this communication facility that we are talking about, so this is the serial communication. So, in 8085 it supports both the types of communication, parallel communication and serial communication. Okay. And this parallel communication can again be classified into classes. This like this this transfer of data. So, it can be unconditional. So, unconditional means that whenever the processor feels like, so it will transfer the data to the device. Polling means the processor will ask the device one at a time that is it ready for the transfer. So, then the data will be transferred that way. Status check, so it will check the device whether the device is ready, and then so the polling and status check are more or less same. They actually the device, the processor will regularly poll the device to check its status, and if the status is okay, the device is free, then it can be transferred. So, this is under the microprocessor controlled facility. Under the device controlled facility, so there can be interrupt. So, device will send an interrupt to the processor, and when that interrupt comes, the processor will transfer the data. So, we have so these are the so challenges that we have are like this. So, we have this requirement to identify the interface. So, for that we have to have some port number through which the device are to be accessed. So, we will see this memory mapped peripheral mapped concept later. Then we have to activate these read write control signals, and we can transfer only one data line can be. So, instead of doing that, instead of doing this parallel transfer, so if we use a single bit transfer, then we will come to the serial IO operation.